Okay, this is part 2 of the Foundations and Rock Strength lesson. You should by now have completed the 2 parts of question 11a on page 17 of your booklet. Let's have a look at some answers. If you look at these photographs, let's start with the Crooked House pub. This is actually in the Black Country in the West Midlands. A very famous pub. If you go inside, nothing is square. Nothing is at right angles to anything else. This is the result of ground compaction. The rocks underneath this pub have subsided. They've compacted down. You can see this has happened unevenly underneath the pub. And as a result, part of the building is sinking into the ground. The second of these photographs is taken at a place called Haysborough in the on the Norfolk coast. And here what we're seeing is a rotational failure. So the bottom of the cliff, which is just made of fairly loose unconsolidated sediment, gets eroded away by the sea because the bottom of the cliff's taken away. The top then sort of rotates around and breaks, and you can see the sort of the step down of the road here. The third one shows ground swelling. So we've got the rocks underneath this building. You can see particularly in the pavement there have expanded and pushed the surface up. The final picture here, this was taken in Scarborough in 1997. This is a place called the Holbeck Hall Hotel, and you can see that the hotel had to close for business after this one. There was a sliding failure. The slope that it was built on gave way, and there was a fairly large landslide that took away enough of the hotel that the rest of it had to be pulled down. Okay, I asked you then how each of these techniques could be used to solve some problems. The concrete raft here is particularly good at separating the building from any weaknesses in the ground underneath. The building, if you like, or the raft sort of, if you like, floats on the ground. So if part of the ground underneath swells up or subsides a little, the strength of the raft will still support the building, so it won't move. It's a very effective technique, does use a lot of concrete, and can only be used on relatively light buildings. You can't put a concrete raft, for example, under a skyscraper, or even a large building like A block. For something like that, built on weak ground, you need these concrete piles. What concrete piles do is they bypass the weak rock. So they take the weight of the building. So for example, the weight of A block isn't resting on the ground around it, or immediately underneath it, should I say. The weight of the building is actually taken by these 20-metre long concrete columns and spread out then over a layer of gravel about 20 metres down. These, they're very effective foundations, but they are expensive to install. But if it's the only way you can build your building, then you need to put them in. Finally then, the drainage system. That controls the water. Remember I said water has a massive effect on swelling, shrinking, strength of rock, all sorts of different features within engineering geology. By being able to control that, you have more ability to deal with weaker ground. So, as we watch the sunset over Kumyoi, we can see that there are a whole host of issues that are created by the geology that we're trying to build things on. It's our job as geologists to understand what those issues are, to be able to predict what they might be, and to design an engineering solution that will allow us to, for example, build a school like A Block on really quite unsuitable ground. How do you actually deal with those conditions to be able to build the things you need where you need to build them? Buildings are relatively easy. When we start digging slopes, and in particular when we start digging tunnels, things get more complicated. But that's for another lesson. I'll see you then.